Okay, so now we are going to study one-dimensional infinite square wave potential, or it is called the particle in a box problem. Actually, this is an application of Schrodinger equation. Okay. Yes, here here we consider the motion of a particle of mass m, confined to move between two walls of infinite height at x equal to 0 and at x equal to L. And so the width of the box is L. So you can see the width of the box is L. Okay. So since there is no force of interaction, and also we consider that there is no force of interaction between the walls of the box as well as the particle. So since there is no force of interaction means the potential energy of the particle inside the box is 0. Since there is no force of interaction means the potential energy of the particle inside the box is 0. That is what is written here. V is equal to potential energy V is equal to 0. But outside the box the potential energy is infinite. Okay. So since the potential energy is 0, it is clear that the potential energy is independent of time. That means potential will not change with the time. For the we have studied that, right? The time dependent potential and the time independent potential. For time independent potential, we have derived the Schrodinger time dependent equation. So there the potential energy was time dependent, but in Schrodinger time independent equation, we have seen that we considered that the potential energy is time independent. So this is a similar case. So here, since the potential energy is 0 and potential energy is independent of time, so we can use the Schrodinger time independent equation to solve or to find out the possible energy values of the particle inside the box as well as its wave function. Okay, so let's do that. How we can derive the energy value and possible energy values as well as derive the wave function of the particle inside the box. Okay, for that we have the Schrodinger equation. Schrodinger time independent equation. Okay, so what was the equation? D square psi by dx square plus 2m by h cut square into E minus V is equal into psi is equal to 0. Right, so this is our equation number 1. So d square psi by dx square plus 2m by h cut square into E minus V into psi is equal to 0, where E is the total energy, V is the potential energy. Okay. So since here actually the potential energy is 0, so we can write or we can avoid the V term here. So we can write since here the potential energy V is equal to 0. Potential energy of what? The particle inside the box. V is equal to 0 for the particle inside the box. For the particle inside the box, inside the box, this equation 1 become how we can write? Yes, d square psi by dx square plus 2m by h cut square V become equal to 0. So E psi is equal to 0. This is equation number 2. Okay. So d square psi by dx square plus 2me by h cut square psi is equal to 0. Here we substitute attain k square for 2me by h cut square. 2me by h cut square is equal to k square. So we are substituting for 2me by h cut square. So the equation becomes d square psi by dx square plus k square psi is equal to 0. So this is equation number. Equation number 3. Okay. Yeah. Okay, we can even give an equation. This is 3a, sorry, 3b, and this is 3a. Okay, so we need this substitution. No, so we have a differential equation d square psi by dx square plus 2 plus k square psi is equal to 0. What is the possible solution of this equation? Yeah, the solution of this differential equation is the solution of this differential equation is what was the equation? Yes, psi is equal to a sin kx plus b cos kx. Right. Okay. So for the differential equation, we get a solution for this differential equation, and this is a function psi is equal to a sin kx plus b cos kx. So now what we are going to do is we are going to apply the accessibility condition for the function to be a wave function. അതായത് ഒരു ഫംഗ്ഷൻ വേവ് ഫംഗ്ഷൻ ആവണമെന്നുണ്ടെങ്കിൽ ചില കണ്ടീഷൻസ് സാറ്റിസ്ഫൈ ചെയ്യണം നമ്മൾ പറയുന്നത് അഡ്മിസിബിലിറ്റി കണ്ടീഷൻസ് അല്ലേ. സോ എ ഫംഗ്ഷൻ to become a wave function should satisfy a few admissibility condition. What was those condition? Yeah, first one was the function should be having a finite value and it should vanish at infinity. The second one, the function is single value, right? And third one, the function and its derivative should be continuous. Fourth one, the function should be square integrable. So such kind of a function which satisfies this admissibility condition can only be taken or considered as a wave function. Okay. Yes. So we are going to apply a few of our condition. First, we are going to apply the continuity condition. Continuity condition on continuity condition on psi. And as we can see in the figure, since it is impossible to find the particle outside the box, right? Because it is the particle is trapped inside the box, and this box is having infinite height wall. So the thing is, the particle will not be able to. We can say it is get trapped inside the box, right? So that it will not be able to come out of the box, right? Because it is having infinite height wall. So as we can say, it is impossible to find the particle outside the box. So that means psi must be having zero value for all points outside the box. So psi must be having zero values for in outside also, because we have even in the admissibility condition as well, we have studied, we have what we have studied. Yeah, the size should be having a finite wherein should vanish at infinity. So because it is infinite point, the box wall is having infinite height, right? So we don't know what will be the particle doesn't know what is outside the box. So it is, you can consider it as an infinity. It is not finite. So that also we can say that outside the box, that is x less than 0 and x greater than L, we can consider psi is equal to 0. So we can write at psi is equal to 0 for x less than 0 and psi is equal to 0 for x greater than L. Okay. So that means x less than 0 ക്കും അതായത് ഈ ബോക്സിന്റെ പുറത്ത് x greater than L, that is outside the box, even outside the box. So ഇതിനിടയ്ക്കാണ് നമ്മുടെ ബോക്സ് അല്ലേ? സോ ഇതിന്റെ പുറത്ത് psi 0 ആണ്. Okay, so if it possible ആണെങ്കിൽ, if it have to happen, so how we can write? Yeah, this is possible only if we can write. This is possible only if psi is equal to 0 at x equal to 0 and psi is equal to 0 at x equal to L. So this is actually we explained it. This we need a continuity condition. Actually, the particle inside the box, if it want to be, if it want to come outside the box, it need to cross the box wall, right? This wall, ഈ ഒരു വാൾ ഇതിന് ക്രോസ് ചെയ്യണം, റൈറ്റ്? അതേപോലെ എക്സ് ഇക്വൽ ടു എല്ലിലെ വാൾ ക്രോസ് ചെയ്താൽ മാത്രമേ ഇതിന് ഇവിടെ വരാൻ പറ്റുള്ളൂ, ശരിയല്ലേ? സോ ദാറ്റ് മീൻസ് ഇഫ് psi is equal to 0 outside the box, that means അറ്റ് ഈ വാളില് ഈ പാർട്ടിക്കിളിനെ കാണാനുള്ള പ്രോബബിലിറ്റി 0 ആണ്. കാരണം വാള് ഇത് വരണമെന്നുണ്ടെങ്കിൽ വാള് ക്രോസ് ചെയ്ത് വരണം, അല്ലേ? അപ്പോൾ വാളിൽ കാണാനുള്ള പ്രോബബിലിറ്റി 0 ആണ് എന്നെടുക്കുക. And also it is, we have already at the beginning we have described that there is no force of interaction between the particle and the wall. അങ്ങനെ പറഞ്ഞ് വെച്ചിട്ടുണ്ട് നമ്മൾ. ഈ പാർട്ടിക്കിളും വാളും തമ്മിൽ യാതൊരു തരത്തിലുള്ള ഇന്ററാക്ഷനും ഇല്ല. അതുകൊണ്ടാണ് പൊട്ടൻഷ്യൽ എനർജി ഇൻസൈഡ് 0 ആയത്. അതുകൊണ്ട് തന്നെ പാർട്ടിക്കിളിനെ കാണാനുള്ള പ്രോബബിലിറ്റി നമ്മൾ ഈ വാളിൽ നോക്കുകയാണെങ്കിൽ 0 ആയിരിക്കും. അപ്പോൾ അത് നമ്മൾ എങ്ങനെയാണ് ഇത് എക്സ്പ്ലെയിൻ ചെയ്തത്? യൂസിങ് ദ കണ്ടിന്യൂറ്റി കണ്ടീഷൻ. psi is equal to 0 outside the box, psi is equal to 0 ആണെങ്കിൽ that means that it will not cross the wall. That means at the wall also, that is at x equal to 0 also, the probability of finding the particle is 0. That is psi will be equal to 0. Right? So, okay, so we can write this is possible only if psi is equal to 0 at x equal to 0 as per the continuity condition. You can write as per the continuity condition. And also psi is equal to 0 at x equal to L. Okay. So now we are going to apply. So we can give this equation number 4. Now we are going to apply this condition. Psi is equal to 0 at x equal to 0 and psi is equal to 0 at x equal to L in equation number 4. So first we are going to apply the first condition, that is psi is equal to 0 at x equal to 0 in the equation number 4. So what will be the equation? Yeah. So we have psi is equal to 0, that is psi is equal to 0 at x equal to 0, that is a sine, substitute the value for x, a sine 0 plus b cos 0. So that means sine 0 is 0, cos 0 is 1. So what we get, b is equal to 0. So substituting this value b is equal to 0 again in equation number 4. What will be the value? Psi is equal, what we will get? Psi is equal to a sine kx. Right. Substitute the value of b is equal to 0 in 4. Equation number 4. What will you get? A sine kx. So this we can give equation number 5. Okay. Okay. So using again the continuity condition that at x equal to psi is equal to 0 at x equal to L, we substitute in this equation number 5. That is psi is equal to 0 at x equal to L. So a sine k L. A sine k L. So a sine k L is equal to 0. So that means here a sine k L is equal to 0 means a will not be equal to 0. Okay, here a will not be equal to 0 because we have seen psi is equal to a sine kx. The amplitude of the function is equal to 0, then it is impossible because then psi will vanish. Psi will get psi 0, right? Psi will vanish if a is equal to 0. So that is not possible. That is impossible. So what is the possible condition? Yeah, if a sine kl is equal to 0, sine kl can be equal to 0. Sine kl equal to 0. This is possible. So sine kl is equal to 0 means sine theta is equal to 0. For what values of theta? Yeah, that is 0, pi, 2 pi, 3 pi, like that, right? So in general we can write theta is equal to n pi. So kl is equal to n pi. Right. So this we can write the equation number 6. Kl is equal to n pi. So where n is an integer. It's an integer. Okay. So substitute this value because in the equation number 5 we have a psi is equal to a sine kx. For k we can get as a value k. Yeah, n pi by n. Right. So k is equal to n pi by n. Substitute here. What will be the value in the equation number 5? So psi is equal to a sine, for k what is n pi by n. So sine n pi x by n. Okay, so psi is equal to sine n pi x by n. Here, if we have n is equal to 0, what will be the value of psi? N is equal to 0. If n is equal to 0, psi also become equal to 0. That is also impossible. Okay, so this is impossible. Right. So then what will be possible? So therefore, n is a non-zero integer. We will not be able to take n is having zero value. N is zero value നമുക്ക് എടുക്കാൻ പറ്റില്ല. So we can take n is a non-zero integer. N is a non-zero integer ആയിട്ട് കൺസിഡർ ചെയ്യേണ്ടി വരും. Non-zero integer. Okay. So that means it can be shown that minus n and plus n corresponds to the same physical state. Corresponds to the same physical state. Okay, so k square, we can just square this equation number 6. Square equation number 6. What will be the value? K square L square is equal to n square y square. Right. So from here, if we substitute for the value k, we have here in this equation number 3a. So we have 2me by h cut square is equal to k square. Right. 2me by h cut square is equal to k square. Right. Yeah. So substitute that value 2me by h cut square. So I will write here 2me by h cut square into L square is equal to n square pi square. Right. That is, from here we can write the value of energy. Right. So in general, because here is an n, so in general we can write the energy corresponding to n, that is En is equal to n square pi square h cut square, n square pi square h cut square by 2ml square. 2ml square. Okay, so this is the energy equation. So we can give a number 7. Equation number 7. So here also actually the value of n is restricted here. We will not be able to take any value. That means n is having value 1, 2, 3, etc. Right. So that means the particle cannot have any value of energy but restricted to certain values only. That is the meaning of this equation. En is equal to n square pi square h cut square by 2ml square. So we can say that the energy is quantized. The particle will not able to take continuous value of energy, but discrete value of energy, or we can say the energy is quantized, and the number n is called the quantum number. Okay, so the energy values are quantized. Okay, yes. So now we can go to derive the wave function. Before that, we can just substitute value of various value of n, and we can see how the equation will. For if n is equal to 1, what will be the En value? E1 is equal to I square h cut square by 2ml square. Right. Similarly, E2, what will be n is equal to 2? Equal to 4 pi square Thus n square, 4 pi square h square by 2ml square. That is equal to 4 E1. Similarly, n is equal to 3, 9 E1. And n is equal to 4, E4 is equal to 16 E1. Right? Yes. Okay. So now we can, go to find the wave function, and we have here we have seen that the wave function of form psi is equal to a sin kx after applying the admissibility condition, right? So we are going to check whether this wave function can be used as a wave function. This function can be used as a wave function to represent the particle inside the box. Okay. So that for that we have we have studied the normalization condition. A function should be normalizable, right? Should be normalized to represent as a wave function. So now we are going to apply the normalization condition in this wave function between the limit x equal to 0 and x equal to L. Okay. So yes, the normalization condition. It was a normalization condition. Yeah, integral minus infinity to plus infinity psi star d tau is equal to 1. That was a normalization condition. Here d tau is equal to dx dy dz. Here actually is a one-dimensional problem. So the particle is only moving in the x direction, right? Yeah. So it's a one-dimensional problem, and we have the limit x equal to 0 to x equal to L. So the normalized wave function can be obtained as the normalized wave function can be obtained as integral minus infinity. Here it is actually the limit is x equal to 0 to x equal to L. 0 to L. It is psi here. A sin n pi x by L. Right, n pi or kx n pi x by L. What is I star? Is the complex conjugate of this function, because this is a real function, so the complex conjugate is the function itself. So again a sin n pi x by L into dx, because it's a one-dimensional problem. It's equal to 1. Okay, so just for simplicity, we can substitute for n pi by L, because scale is equal to n pi. We have seen that, so we can just write sin kx. That will be easy, to solve this equation. In the final step, we can substitute for the k value. Okay, and a sin kx dx is equal to 1. So this becomes a square. You can take it outside, a square, because a dA is equal to a square. Integral 0 to L sin square kx equal to 1. So how we can integrate sin square kx? So there we need to write this equation in the form 1 minus cos 2 kx. So that we have studied how we can integrate sin square theta. Yeah, we need to write sin square theta in terms of cos 2 theta, right? 1 minus cos 2 theta by 2. We have studied in the cos 2 class. Okay, so sin 1 minus cos 2 kx by 2. So the 2 we can take it outside. So 1 minus cos 2 kx into dx is equal to 1. So here also there is a dx. Okay, dx. Yes. Okay, so now we are going to integrate this equation. So integral 0 to L 1 dx, that is x, right? A square by 2 integral 1 dx, that is x. X. What is integral cos 2 kx? That is sin 2 kx by 2k. Sin 2 kx by 2k. The limit 0 to L. Right, that is equal to 1. Yeah, so now we are going to substitute the limit. Yeah, so for x, that is L minus 0. That is, we can write a square by 2 into L minus 0. Okay, so we don't need to write that. And for sin 2kx by 2k, so substitute the value sin 2kl by 2k. And sin 0 is equal to 0, so that we don't need to write. So sin 2kl is equal to sin 2k. What is the value of sin 2kl? Yeah, we have seen that sin 2kl is the value sin 2kl. So if we substitute the value for kl, sin 2kl is equal to, so for kl we can write n pi, right? Sin 2n pi. That is also having the value. What is sin 2n pi? Yeah, sin 2 pi, 4 pi, 6 pi, like that. For n is having value 1, 2, 3, right? So that is also the value is 0. So that term we can neglect. So sin 2k term will be become equal to 0. So what will be the remaining? A square by 2 into L is equal to 1. A square by 2 into L is equal to 1. So here that one you can you can write a square L by 2 is equal to 1. So here we can write, or we can write here a is equal to, what will be a? A square is equal to 2 by L, a is equal to square root of 2 by L. So this is called a is equal to square root of 2 by L. That is called the normalization constant. Normalization constant. Now, what is the meaning? So if we substitute the value for a in this equation for a sin kx, that is square root of 2 by L, then we integrate that equation between 0 to L. What we will get in this equation? Yeah, we get 1. So that is why it is called a normalization constant. അതായത് എയുടെ വാല്യൂ സ്ക്വയർ റൂട്ട് ഓഫ് 2 by L ആണെങ്കിൽ മാത്രമേ നമുക്ക് ഇത് ഇന്റഗ്രേറ്റ് ചെയ്യുമ്പോൾ 1 കിട്ടുള്ളൂ. That is meaning. Okay, so we can write, so we have normalized the wave function. So we can write the normalize the wave function as, so therefore the normalized wave function of functions are ഒരു വേവ് ഫംഗ്ഷൻ ആണുള്ളത് കാരണം എന്നിന്റെ വാല്യൂ ഡിഫറെന്റ് വാല്യൂ അനുസരിച്ച് we have different we have psi 1, psi 2, psi 3 like that. So generally we can write psi n is equal to square root of 2 by L, yes, to sine n pi x by L. Right, for n is having value, n is having 1, 2, 3, etc. Okay, so we can give a number, question number 8. Okay, so yeah, we get the both the energy value and the wave function. We have derived the energy value as well as the wave function. Right. So what will be the, if we substitute the value for n is equal to 1, what will be the value? So n is equal to 1 is the ground state wave function. Because here we will not be able to take n is equal to 0. As we have discussed, if n 0 assign 0 wave function exist ചെയ്യത്തില്ല. So n ന്റെ value ഒരിക്കലും 0 ആകത്തില്ല. So ground state എന്ന് പറയുന്നത് n is equal to 1 ആണ്. n is equal to 0 എന്ന് ഒരിക്കലും എടുക്കരുത്. So the ground state wave function is actually the ground state wave function. State wave function. This for n is equal to 1. Yeah, psi 1 is equal to square root of 2 by L. Yeah, sine pi x by L. So for n is equal to 1, and for n is equal to 2, the wave function of the first excited state is wave function of the first excited state is psi 2 is equal to square root of 2 by L, yeah, sine 2 by x by L. Right. So like that we can write psi 3, psi 4 like that. Okay. So anyway function we can write. So now we are going to analyze the probability distribution. Okay, so that we can take the next page. The probability distribution. How the probability distribution? Yes, the probability distribution. So for calculation of probability, we use our normalized wave function, because we have already normalized the wave function, right? So in order to calculate the probability, we need the normalized wave function. So we have the normalized wave function, sin of x is equal to those equations. Sin of x is equal to square root of 2 by L and sine n pi x by L. Right, sine n pi x by L. So that is the normalized wave function. So consider we consider 2 points x and x here, and after a distance dx, in this very small distance dx, we find another point x plus dx. So the distance between, or the width between x and x plus dx is dx, right? Okay, so now we are going to, we are just going to find the probability of finding the particle between x and x plus dx. That is through the width dx, right? So how we can find the probability of that particle? So for that we can write probability of that particle between x and x plus dx. Yeah, so there actually we need to consider the wave function psi, and we have studied the probability density psi star. You remember that psi star, that is a probability density per unit volume. So in this case actually this is probability density, right? Probability density psi star. So in this case this is actually probability per unit length. Okay, so what we are going to do is we have a length dx. So for unit length, psi star is the probability, and if it is for dx distance or dx length, what will be the value? So this is actually psi star. Psi star is equal to probability per unit length. Okay, so psi star into dx is actually for unit length it is psi star. Then for what will be the value for dx length? Okay, what is the probability dx? That is what we are going to write. Psi star dx, that is equal to what is psi? Square root of 2 by L sine n pi x by L square root of 2 by L sine n pi x by L. So, or we can say unit length in a probability is psi star. English dx length, that is psi star dx. Okay. So, other than that, dx length probability then it will be easy to find the probability between any 2 points. Okay, so we just need to add up for dx, or we can just integrate within the limit. So in that case, if we consider for the interval, so that means if you find the value, find the probability for dx distance, then it will be easy for us to find the probability value in between any 2 points if the value is the limit is given. Okay, so for example, for the interval x1, we consider just two interval x1 and x2. Maybe it can be here or here, x1 is here or x2 is here, like that. So just we take two interval x1 and x2, and the probability x1 x2 is equal to integral x1 to x2. What will be the equation? The integral, the thing is, that is in between x1 and x2 there will be a number of dx, because dx is very small distance. So for the case of dx, we have written psi star dx. So if there is n number of dx distance in between x1 and x2, what will it be? We need to find for each dx, to find the probability value for each dx, and we need to add up. So for that, what we will do usually? We just need to integrate between x1 and x2 between that limit. Integrate within the limit. So here it is x1 and x2. So what we can write? That is square root of 2 by L sine pi x by L into square root of 2 by L sine n by x by L into dx. So dx distance probability size star dx ആണ് നമ്മളോട് എഴുതിയിരിക്കും. So dx is here. So ഇതിപ്പോൾ വേറൊരു ലിമിറ്റ് തരുവാണ് x1 and x2 തരുവാണെങ്കിൽ സോ അതാണ് ഇവിടെ പറഞ്ഞത്. So we need to integrate അല്ലെങ്കിൽ ഓരോ ഈ x1 x2 ഇടയ്ക്ക് n number of dx ഡിസ്റ്റൻസ് ഉണ്ട്. ഓരോ dx ഡിസ്റ്റൻസിലെയും പ്രോബിലിറ്റി കണ്ടുപിടിച്ച് ആഡ് ചെയ്യാം. അതിന് പകരം നമ്മൾ എന്ത് ചെയ്യുന്നു? ജസ്റ്റ് ഇന്റഗ്രേറ്റ് within the limit x1 to x2. Okay, so it's very simple. Yeah, so the probability density here, we have already discussed that the probability density is, what is the probability density? Psi star, right? Density. What was the value? Psi star, that is modulus of sine of x square. Right. So the probability of finding the particle between x and x plus dx is, that is within the box, sorry, x plus dx within the box is, that we have already written here. Right. So what we can write? Yeah, probability density. Yeah, probability density. Sorry. Okay. So the probability of finding the particle, probability of finding the particle between x and x plus dx within the box it is equal to p is equal to modulus sin of x square, that is equal to square root of 2 by L into square root of 2 by L, that is 2 by L sin n by x by L into sin n by x by L, sin square n by x by L into dx. Okay. Yes. So now we are going to draw two figures or two graphs to show the wave function of first three energy levels, and then we draw a probability distribution of for the first three energy levels. Okay. So now we are going to draw a graph based on the energy levels and the wave function. Okay, so you can write E1, these are the different energy E1 energy levels, different energy levels E1, E2 and E3. So corresponding to these energy levels, we have psi 1, psi 2 and psi 3. So we are going to draw how the wave function will be performed for these different energy levels. So first, for n is equal to 1, we have psi 1 of x is equal to square root of 2 by L sine pi x by L, and psi 2 of x is equal to square root of 2 by L sine 2 pi x by L. Right, and psi 3 of x is equal to square root of 2 by L sine 3 pi x by L. Okay, so So in that case, we can substitute how we can draw the wave function for psi 1 of x is equal to square root of 2 by L sin pi x by L. How we can draw that? Okay, so now we are going to analyze for the value of psi 1 of x, that is equal to square root of 2 by L sin pi x by L. For value x equal to 0 to x equal to L. Okay, so for what value? For example, at x equal to 0, what will be the value of psi 1 of x? Yeah, sin 0, that is equal to psi 1 of x at x equal to 0, 0. Right. And psi 1 of x at x equal to L, what is the value? Psi 1 of x at x equal to L, x equal to L. What will be the value? Yeah, square root of 2 by L sin pi L by L, right? Square root of 2 by L sin pi L by L. So this L cancel out. What will be the value? Square root of 2 by L sin pi. Sin pi also equal to 0. So that is at x equal to 0 at x equal to L, the wave function is 0. Psi 1 of x is 0. So then we can look at the center, that is at the x equal to, this is from x equal to 0 to x equal to L. So what will be this point? It is L by 2, right? The center point. L by 2. Just check it, what is psi 1 of x at x equal to L by 2. So we can write square root of 2 by L sin pi. For x we substitute L by 2 into divided by L. So this L cancel out. So square root of 2 by L sin pi by 2. It is equal to sin pi by 2 is equal to 1. So square root of 2 by L. Right. So if we start the graph from here, this is a sine function, is having 0 value at x equal to 0. Right, psi 1 of x at x equal to 0 is 0. Yeah, here. And psi 1 of x at x equal to L also 0. But it is having a maximum value at L by 2. So how we can draw the graph? X equal to 0, the graph will start from 0 and it will be having a maximum value at x equal to L by 2, and then it will come to 0 at x equal to L. So it's a form of the wave function at the energy level E1, and write psi 1. Okay, so it's a smooth line. We are drawing with the pen, so that's why it is like this. So when we draw, please draw it smoothly. So similarly, we can draw for psi 2x. So psi 2x, while we take psi 2x, we need to find out what is the value of psi 2x at x equal to 0. This is 2 by L sin 2 pi x by L sin 0, right? That is equal to 0. Psi 2x, what is the value of psi 2x at x equal to L? That will also be equal to sin execution sin 2 pi L by L. So sine 2 pi, that is also equal to 0. So now we can, we need to divide this equation. No, we can take from x equal to 0 to x equal to L. So for what values we will get different value of sine theta. So sine theta is having maximum value plus 1 and the minimum value minus 1. So for what value here we can have the maximum value and minimum value of sine theta. Yeah, if we substitute for x is equal to L by 4, this become sine pi by 2. Right. So let's do it. X is equal to, or we can yeah. So just do it. Sine 2 of x. X is equal to L by 4. So actually here this distance x equal to 0, x equal to L. So we can divide this as a product of as a segment of L by 4. So L by 4. So this is L by 2. So between L by 2. So this is, so each segment is having a width L by 4. L by 4, L by 2 plus L by 4. What will it be then? 3 L by 4, right? 3 L by 4 and then plus L by 2. Then L by 4 is equal to L. That is 4 L by 4, right? So this is the case. So we can substitute, we can find the value for each, segment L by 4, L by 2 and then 3 L by 4 in the L. And x equal 0 and x equal to L we have already find out. So what will be the value of the L by 4? Yeah, L by 4 we can substitute x is equal to L by 4. What will be the value? 2 pi x L by 4. X in L by 4. So that will become 2 pi into L by 4 divided by L, right? Square root of 2 by L sine 2 pi L by 4 divided by L by 4 divided by L. So this L cancel out. 2 and 4. 1, 2 will go out, cancel out. So what will we get? Square root of 2 by L sine pi by 2. That is equal to square root of 2 by L. Okay, so similarly for psi 2 of x at x equal to L by 2, what will be the value? Yeah, for L by 2, we substitute for x, what will be the value? Yeah, L cancel out, 2 cancel out. So sine pi, right? So square root of 2 by L sine pi we get. So that is equal to 0. And for 3L by 4, what will be the value? 3L by 4. Okay, so similarly we can calculate the value for x is equal to sine 2 of x at x is equal to L by 3 L by 4 and L by 2 and 3 L by 4. So 3 L by 4, what will be the value? Square root of 2 by L sine 2 pi 3 L by 4 x in over 3 L by 4 divided by L. So what will be the value? That is equal to 3 L cancel out. What will you get? Square root of 2 by L sine 3 pi by 2. It is 3 pi by 2. minus 1, right? Minus square root of 2 by L. Okay, so this is, okay, so how we can draw that? So for that we need to divide into 4 parts, equal parts, L by 4 segment. Right. So at x equal to 0 it is 0. At x equal to L by 4 it is maximum value. Right. Square root of 2 by L. So at x equal to L by 2 again 0. So how we can draw that? X equal to 0, 0. And this. Right. That is at x equal to L by 4 maximum value, L by 2 0. Similarly, 3L by 4. 3L by 4 it is having minus square root of 2 by L. So the graph will come like this. Okay. Yes. Similarly, we can draw, for side 3. This is side 2 of this. How? Yeah. So now we can check for side 3 of x. What is side 3? Side 3 of x is equal to another side 3 of x is equal to square root of 2 by L sine 3 pi x by L. Right. So like this, for we can divide, or we can take the segment. Just to look at this space of 3 pi x by L. So for maximum value of sine, what will be the theta value or x value? And we need to get pi by 2, right? Pi by 2 or a multiple of pi by 2, right? So here also, actually, the previous case we have divided it into 4 sections. L by 4, L by 4, L by 4 plus L by 4 plus L by 4 plus L by 4. In this case, how much section we take between x equal to 0 and x equal to L. Yeah. So we can take, like, for pi by 2, what will be the x value? L by 6. If we take x is equal to L by 6, we can get pi by 2, right? 3 pi L by 6 in there. So 3 can cancel out, pi by 2 we get. So that means we can divide this entire length into, equal section of L by 6. That is L, this is entire width L into equal section of L by 6. So the middle section is L by 2. Right. So each section become L by, so 3L by 6 is equal to L by 2. So 3 section 2 L by 6, 2L by 6. 2L by 6 is L by 3. And L by 2 again, we need to add up. I need to find the value. Okay. So that you should do as a homework or as your work. So for each value of L, we need to find the value. So in that case, actually, as we can see, so for example, for here also at x equal to 0 and x equal to L, side 3 vanishes. Side 3 is x equal to 0, 0, side 3 of x at x equal to L, 0, side 3 of x at L, x is equal to L by 6, it is equal to Yeah, square root of 2 by L, because sin pi by 2. If we substitute for x is equal to L by 6. And again for L by 3, L by 3 substituting, what will be the value? Yeah, L by 3. So again sin pi, right? If you substitute for x L by 3, again, yeah, sin pi, again 0. So sin 3 of x at x is equal to L by 3 is equal to 0. Then sin 3 of x at x is equal to L by 2. What is L by 2 value? Yeah, again L by 2. So what will be the value? Yeah, sin 3 pi by 2. Sin 3 pi by 2 is minus 1. So minus square root of 2 by L. Right. So again L by 2 plus L by 6. What is the value? Again, so this is 3 L by 6, 4 L by 6, right? 4 L by 6 is actually 2 L by 3. Here is actually 4 L by 6, right? So sine 3 of x I will write here. Sine 3 of x is equal to 4 L by 6. Because we are adding L by 6 segments, 4 L by 6 and 5 L by 6. Next one is 5 L by 6 is equal to 5 L by 6. So what are the values? Yeah, for 4 L by 6, what will be the value? Yeah, substitute there. 4 x is equal to 4 L by 6. So 4 L by 6 there, L cancel out, 4 by 6. That means 4 pi by, what will be the value? Square root of 2 by L sin 3 pi into 4 L by 6. L cancel out, so 4 by 6. So 3 get cancel out, 2 get cancel out, again pi. So that become equal to 0. Right. Similarly, at x is equal to 5 L by 6. What will be the value? Square root of 2 by L sin 3 pi 5 by 6. So what will be the 5 pi by 2? 5 pi by 2. So 5 pi by 2 is, this is only 5 pi by 2. Yeah, it's plus 1. This is the square root of 2 by L. Okay, so this is the way we can find the value of sin 3x at a different point along x equal to 0 to x equal to 8. So what we do here? Yeah, first we need to mark the points. So this is okay. So this is L by 6, L by 2. This is 5 L by 6. Okay. Yeah, so to start at x equal to 0, L by 6 it is having maximum value, and L by 3 it is 0. So how it will go? It will go like this. And L by 2 it is having, what is the value L by 2 at L by 2? Minus, like, yeah, it's minus value. So it will come down. And at 4L by 6 again it is 0 value, that is this point. So again at 5L by 6 it is having maximum value, plus value, right? So we go like this, and at L it is again 0 value. So this is the way we get the psi 3. Okay, so I hope you understand how we draw this figure. So while you try to draw this figure, so please go through these steps, and once you understand the value of psi 1 of x at a different value of x, and the psi 2 of x at a different value of x, and psi 3 of x at different value of x, then it will be easy for you to draw the graph. Similarly, we can draw the graph for the probability distribution. So here it is for wave function, and that is the wave function for first 3 energy levels. This is wave functions for first 3 energy levels. So the first 3 energy levels. Okay, so wave functions of the first 3 energy levels. I hope it is clear. So now we will go to the drawing the probability distribution of first 3 energy levels. Probability distribution of first 3 energy levels. Okay, so now we can draw that. We have the equation for probability P is equal to square root 1 sin of x square dx, that is 2 by L sin square n pi x by n pi by L n pi x by L into dx. So we can calculate for each state. For n is equal to 1, that is equal to 2 by L sin square n pi x by L. Right, so this is actually more or less I square, right? So if you draw this figure, actually we just need to square the value of the previous calculations, right? So the previous calculation we have, we have seen how to draw the wave functions. So here actually psi star is actually psi square. So while we draw the graph, we can just take the previous slide, and that's actually we just need to square. So the minus value actually it gets squared and it becomes plus. So while we draw the graph, actually for the ground state E1, that is the same graph, but now when we draw this E1, E2 and E3, actually the separation, if you really draw this based on the magnitude, that will be the difference. E1 is equal to 4, sorry, E2 is equal to 4 E1, E3 is equal to 9 E1, like that. So that when we try that in the proper manner, we need to consider that distance as well. Okay, so but here actually we just need to represent the probability function. We just draw. Okay, so the amplitude also will change to 2 by n. Previously it was square root of 2 by n, so it is actually the get squared while we compare to the previous figure. So here is also we can draw the maximum value, at x equal to 0, the same value sin square n pi x will become 0 at x equal to 0 and x equal to L, and is having maximum value at x equal to L by 2. So the thing is, we just square the function. Okay, so I will draw smoothly, and the second section, actually previously it was one up and one down, curve is here. So while we square it, it will come out. So when we draw that, okay. So similarly, in the previous figure we have one up, one down, and one up. So the down will come. In this figure it will come up. So like this, we will get the function. So we can write psi 1 star, psi 2 star, and psi 3 star. Okay. So this is the probability distribution for the first representation of the first 3 energy levels. Here also actually, now I will draw these notes. Like this. Okay, so I hope it is clear. So this is just we have a squared the wave function. So psi star. So that's why the function came like this. So the thing is, while you draw, keep in mind that all is having the same intensity. That is, the amplitude is 2 by L. Okay, so while you draw, please make sure that all look like the same amplitude. Okay then, so we finish here.